Okay, well today, as you can see, we're going to be working on addition of polynomial notes. So we're going to name each polynomial by degree and number of terms. Degree is what is the greatest exponent. So let me come over here and it says, come on, I'm trying to do this. There we go. So we've got a 6r raised to the 5th power minus 9r raised to the 3rd power minus 3r squared plus 10. So the biggest number on that is, of course, our 6r to the 5th power. So that's the one that we want right there. That is our degree. Oh, come on. I need to focus this. There we go. So it's 5 is our biggest exponent. When we name a polynomial, if it is a single term, with 1 it is a linear term, 2 would be quadratic, 3 would be cubic. Anything over that will be whatever the number is as a cardinal value, so 4th, 5th, 6th degree. So this is a 5th degree polynomial. Let me go ahead and get that out of there. I'm just going to take those out for right now. So we've got a 5th degree polynomial, and it has 1, 2, 3, 4 terms. Terms are separated by pluses and minuses. Okay? Right, second one over here. This is and this is assumed to the 1st power, so it is a linear. And since there is only one term here, it is a linear monomial. Okay. This has no variables, so it does not have a degree. That means it is a constant term. That's what we just call it, a constant term monomial. Okay. All right, this one has a power of 2. That means it would be a quadratic function, and there's only one because there's not anything added or subtracted from it, so a quadratic monomial. Alright, down here our highest power again is 2, so that also makes it a quadratic, but it's got 1, 2, 3 terms, so it's a quadratic trinomial. And then finally, again, we just have one here. It is linear, and it's a linear monomial. Okay. If it had 2 terms, it would be binomial. 3 terms would be trinomial. After that, again, we just say with 4 terms, 5 terms, 6 terms, whatever. All right. So our next one here. We're going to simplify each sum. Let's start out with something fairly simple, something that has only one variable and a maximum of 3 terms, and we have 2 sets of terms. So what we want to do is we want to find, you may want to actually, there's 2 ways to do this. If you have to, you might want to write it like this. 3k cubed, this is still going to be in parentheses, that's taken care of, minus 2k plus 7. So it's all in nice neat order, and we're going to add to that, let's see, we've got 8k cubed plus 7k plus 4. Then once we get everything nice and neat, the next thing that we're going to do is that we're going to combine again our like terms. So I've got a k cubed here and a k cubed here. So I've got 3 plus 8. Well, actually, I'm just going to write them here. 3k cubed plus 8k cubed. Take and mark those out. I've got a k term here, which is negative 2k. We have no k squareds, plus a 7k, and then we got a plus 7 and a plus 4, and then we're going to add those together. So 3 plus 8 is 11k cubed. And if I take 2k's away from 7k's, I get plus 5k's. And then finally, 7 plus 4 is 11. Okay? Now, if you do not have to rewrite these, if you can kind of keep them in your mind, what's in order. So, the other way to do it is I'm going to see which one is my highest power. This is cubed. This is cubed. So I'm just going to go across and say, you know what? I've got 6 n cubes here. I've got 1 n cubed here. That makes it a total of 7 n cubes. Okay. Then I'm going to see if I have any n squareds. I have no n squareds, but I do have n's. I've got negative 8 n's here, and I've got another negative 8 n here. So a negative plus a negative still remains negative. Negative 16 n's. And then I've got a plus 6 and a plus 2, which gives me plus 8. Okay? So if you are able to do that without having to rewrite everything, that's great. On the other hand, if you need to rewrite it, that's fine too. Okay? Alright, so here's our next one. So I've got an r squared here, an r plus 4. I've got an r cubed, an r squared plus 2. So the one that is greatest right now is r cubed. So I'm going to do r cubed here. Now sometimes I will just circle, say I'm done with that one. And then I've got 5 r squareds here and 6 r squareds here. Means I've got 11 r squareds. Okay, then I've got just plain 6 r's with no r's in the next parentheses. And then I've got a plus 4 and a plus 2 makes it plus 6. Okay. And then over here, I've got 4x, 6x cubed minus 6x squared, plus 3x squared, plus 7x cubed, minus 4. Okay, so I've got a cubed here, and I've got a cubed here. 6 plus 7 is 13 x cubes. Now, if you need to, if you might want to use different symbols or different colors so that you're not getting these all mixed up. Okay, well, I'm going to use a different color here. So I've got a negative x squared and a plus 3x squared. So that's going to give me a total of plus 2x squareds. Let me grab one more color here. Let's see. I guess I'll try yellow. I haven't tried yellow yet. Okay, so then I got, ooh, that's not going to be a good one. How about purple? Got a single 4x here. And might need a one more for that last color. Let's grab a green. And then we've got subtract 4. Alright. So we're just simplifying these symbolically. First round. Alright. Well, now look what they did. They went ahead and added a third set of terms. Third function. So I'm going to look for my highest power, which in this case is P3. And I'm going to see if there's another P3 over here. And I've got P3 here. So I have a negative 1 P3, a negative 2 p3s, so that would give me a total of negative 3 p3s. And then I've got 2 more p3s. Well, really, this plus 2 and this negative 2 p's, they would add out, which would leave me with a negative 1 p3. Okay. And I've got 3 p squareds and no p squareds there, but I've got going to take away 4 p squareds there. So 3 minus 4 gives me a negative 1 p squared. So what I'm going to do is I'm going to put those in boxes. Okay. Then I've got just a constant number here. I've got a p here, and I've got minus 7 p's here. So 5 p's minus 7 p's will give me negative 2p. Just going to circle those. And then finally I've got my constant term here, which is 4 plus 5, which is 9, plus 2, which would be 11. Okay. Now, like I said, you can do that if you're comfortable with it. On the other hand, like I said, you may have to write them all out. So let's go ahead and put these in order so that we've got, oh, and there's one more way that we can do this. So the other way, that the last way I'm going to do it is that I'm going to, oh, I don't know why that thing keeps on doing that. I don't want it on autofocus. Just keeps on doing autofocus, and I'm tired of it doing that. It just wants to keep on doing autofocus, and I really don't like it. And I don't have settings on here anymore, I guess. Guess not. Okay. Well, sorry about that, guys. Let's see about what that does. Okay, let's see if that takes that off. Hopefully. That way maybe it won't keep on doing that every few seconds. Okay, so the other way that we can do this is that we're going to take our first thing, we're going to look at our first term within here, first set of parentheses, first function, and we're going to rewrite this, and we're also going to include, we're going to write this as a column. So I've got, and this is really the way I prefer it, 5x cubes plus 7x squareds. Okay, I have no x's, so 0 x's plus 8. Okay, I've taken care of all of those. Now, 8x cubed minus 8x squared plus 4x's plus 0. So anytime I have something that isn't there, I'm just going to put a holder there. Okay. And then our last one, let's do this in blue. Alright. I've got 7x squared. See, now I don't even have to worry about whether something's out there or not. Negative 1x cubed. Please make sure that you do put your number there, though. Minus 1x minus 2. Now, if I had not written so big, I could do column or addition right now, which is what I'm going to do. So I'm just going to draw a little line here, but we're going to write the answer right there. Okay, so 5 plus 8 is 13, minus 1 is going to give me 12. 12x cubes. Right. 7 subtract 8 gives me a negative 8x squared, plus 7 is 6x squared. Oh, we could have said 7 plus 7 is 14. Subtract 8 gives us 6. Alright. So now I've got 0 plus 4 plus 1. Well, that's really 4 minus 1. That gives us plus 3 x's. And then 8 minus 2 is a positive 6. And there's your answer. Alright. That is really the way that I prefer to do it. So let's try it one more time. I've got a cubed, squared, first power, cubed, and cubed. So our highest power is cubed. So I'm going to say 6a cubed. I'm going to write a little bit smaller this time so I have some room here. And then I'm going to have my plus 8a squareds plus 3a's plus 0. Okay. And then I'm going to add to it 7 plus 5a's plus 5a's cubes. Yep, that is cubed. Plus 0a squared. Okay. And then we're going to have 6a's plus 7a cubes. I'm going to have to write it out here to the side again. Let's see. Plus 8 minus 5a squared. Okay, again, we would add these up, but I don't have enough room, so I'm going to bring it over here. So 6 plus 5 is 11, plus 7 more is 18. 18a cubed. Okay. 8 plus 0 is 8 minus 5, so plus 3a squared. Well, these are all positive, so that's going to be positive number. 3 plus 5 is 8, plus 16 plus 6 is 14, 14a's, and then 0 plus 7 is 7, plus 8 is 15. Okay. All right. Next one. So again, I see a cubed. So I'm just going to start out with cubed. I'm going to start over here. I'm going to have, well, let's see about if we just leave myself some room over here. Negative 3x cubed. Let's see. Plus 0x squared. So I see no x squareds. Minus 8x's. Plus 2. Takes care of my first one. Then we're going to have an x squared. Oops. Minus 6x's. Let's see, minus 6x minus 5 plus 0x cubes. I'll make sure that everything is accounted for. Then we have plus 5x's, and this will become very clear why I'm doing it this way when we get to division of polynomials and when we get to multiplication of polynomials. Subtract 6x and then minus 8x cubed. Alright, those added up gives me a negative 11x cubes. That's 6x squared. So negative 14x plus 5 would give me a negative 9x. Negative 3, negative 9. Okay. Alright. Just a few more to do here. I've got a lot more to do. So, gives you some idea of what is going to be expected. We'll go ahead. Oh no, we're jumping into the next section. Okay, so far we've been dealing with one variable only, but now we have a combination of variables. We've got a squares, b cubes, b squareds. So we're going to have to watch what's going on. So when we have something like that, you want to go in decreasing order on your A terms, or whichever one comes first in the alphabet, and increasing on the B terms. Okay? So I'm going to look for something that has something like A cubed but no B's. Okay? And so I've got B squareds, I've got A squareds, I've got A squareds, A to the first, A squared, B squared. Okay, so it looks like my largest term here is going to have A squared. So I'm going to do 5A squared. And it may even help if you put in here, remember, if we don't have anything, put in there B raised to the 0 power. And then I'm going to have plus 3A squareds times B cubes. And then I've got plus 8B squareds. Okay, then we got 3AB squared. Well, I don't have anything down here that says 3AB squared, so that's going to have to come out here somewhere. Because we cannot combine it unless it's absolutely exactly the same. And I don't have anything in here that's just A squared. So I'm going to take and subtract out here A squareds. But I do have something that has a plus B squared. Alright. So, really my highest power is this one, because it makes it a 5th degree polynomial. 2 plus 3 makes it 5. This is only a 2nd degree polynomial. Oh, that does make it A squared. Okay, hold on one second. That should be minus 8A squared. B is 0 power. Never mind. Okay. So, but still, this is a 5th degree polynomial. So if I take this, this is going to give me negative 3A squareds. It's going to give me plus 3A squared B cubed. It's going to give me plus 9B squared plus 3AB squared. Okay? And then again, if I was going to rewrite it, we could rewrite it in decreasing terms, and let's see. A squared B cubed might be the first, would be the first one that we'd write out there if we're going to put it in degree. So 3A squared B cubed is taken care of, and then we would have our third degree. So would be this one, 3AB squareds minus 3A squared plus 9B squared. This one, there's kind of really not any rhyme or reason to it. Okay. Alright. Now let's look at this one. We've got, well, I will as soon as I get my cord out of the way so I can get this page moved up. So sometimes you might want to just look for patterns. Got 8xy squared and another 8xy squared minus 6x squared y cubed plus ax squared y cubed plus 8xy 6xy. Okay, so every one of those has a term to match up. And the reason I say you want to watch for patterns is sometimes they will actually add out. They'll be add-ins of each other, and so you'll end up with a constant value of like 1 or 0 or 5 or something like that. Okay. All right. So my highest degree is the x squared y cubes. So negative 6x squared y cubed. And then this is my 3rd degree polynomial. 8xy squared. And this is a 2-degree polynomial. This is a 2-degree term. And then my x squared y cubes plus 6xy plus 8xy squared. Alright, now we add these two terms together to get 2x squared y cubes. We add these two together to get plus 16xy squareds. We add these two together to get plus 14xy's. Okay. Alright. Now what I have done is that these last few problems on this back page here, we got 1, 2, 3, 4, 5, 6 of them. That is going to be your assignment for today. Okay? And when you come into class tomorrow, I am going to randomly assign you a question, and you're going to type in your assignment, because I'm going to say, here's the assignment that you will get. You like, for instance, I might say, I'll use my son's name, Brian. Brian Doherty, you have been assigned question number 17. For your assignment today, please type in to the, please send me a picture of question number 17. You just have one question, but you don't know which question I'm going to assign you. Sorry about that. Okay, so